So, looking ahead. So this week, the rest of this week, we took the test yesterday. If you didn't take that test, make sure that you get into the research center and get that done this week. Okay? Today we're going to start section 6.6, which is going to be all about complex numbers. We gave you the notes packet yesterday after the test, and we asked you to do the first front and back on the first sheet. So if you have that done, that's great. That'll help you out. That's just a refresher from Algebra 2. If you don't have that done yet, make sure you get that done soon. If you didn't notice, the answers to all of those examples are at the bottom of the back side of that sheet. Okay? Then tomorrow and Friday, we are going to be doing the Launcher Lab, okay, which is the most exciting 2 days that we have in pre-calc, because what you're going to do starting tomorrow is you're going to figure out how to launch a steel ball off of that countertop back there, and you're going to launch it up through a ring, and then you're going to land it in a specific spot. And so it's super duper cool, and it's a lot of fun, and it's all the parametric maths that we've been doing over the last couple of weeks. Okay? Then next week we have a short week. And next week, you don't have school on Friday next week, so we only have 3 days of pre-calculus, and we will basically finish up complex numbers next week, finalizing it with on Thursday. We will be taking a formative next week, Thursday. Okay. Then the following week after that, then we're going to go into polar numbers and polar graphs for that. And then that will take 1 week to do, and then we'll take a test on the 7th of May that will include complex numbers and polars. Okay? Then we will take the EMPT test once again on the 8th, which is the Wednesday. You took the EMPT test at the beginning of the year. This is going to be then your second one, and we're going to compare the results. More than likely, you will have improved your results because you'll have learned all of the tricks since then. And then we're starting our NTC final review. So 9 and 10 we will be reviewing for the final. And I think our plan right now is to test on 14 and 15 will be your NTC final. Will be on the 14th and the 15th. And then the 16th is what? It's 2 days long because it's a 2-hour test and we only have 1-hour classes. It is 100% paper and pencil. 100% short answer. Yep. We do. We have to grade it then. We have to turn around and grade it right away because we need to have it graded by Thursday because you have to accept or deny the credits if you want them. Okay. What was that? It's like I said, the fourth quarter goes. Yeah.
Do we even have a final then at the end of the year?
We will. That will be the majority of your final,
Okay.
and then underclassmen, non-seniors will have a final scheduled during finals week because we have too many of them to not give them. So.
Okay.
Yep. Okay. I know. Trust me, I was advocating for no final also because that's going to be your main final, but then we'll have a secondary final on, and that will be the final will be an over-glorified quiz on what we do after the seniors.
So okay.
Yeah, it won't be on the whole year or anything like that.
I was just wondering.
Yeah. So your NTC final is on the entire
Yeah,
year.
that makes sense.
Yes.
So does our NTC final also go in as our final grade as well?
Yes.
And then like the over-glorified quiz?
Will just be added, will be a second column. Yep. Okay. All right. So let's talk some complex numbers. Now, in life, there are real numbers, there are imaginary numbers, and then there's complex numbers. Complex numbers are made up of both real numbers, that's this A part right here, And they're also made up of the imaginary part, which is this BI part. My P didn't. Now it's bad. P. Okay. So we can graph them on the complex plane if we put them in the ordered pair form A, comma, B, where A is the real part and B is the imaginary part. And you don't have to put the I for that one. Okay? You just have to put the number, however many I's you have. Okay? So that we can then graph them on the complex plane. And the complex plane here would have real numbers going the horizontal, much as the X, and imaginary numbers going up and down the vertical, much like the Y. Okay? Each and every. Oh, no, that's okay. That's what I'm looking ahead. That's fine. Okay. All right. So, if we're looking here at Z, we call our complex numbers Z. Okay. So we'll have Z sub 1, Z sub 2, etc. All that stuff. Z is negative or 2 minus 5I. That is the complex number. Okay. The point form for that then would be 2 comma negative 5. Would be the other way of calling that. And the point 2 comma negative 5 on the complex plane, again, the complex plane is real and imaginary. So now we would be 2 to the right and 5 down. So this would be the complex ray, then, or the number. Each and every complex number is a certain distance from the origin. We're going to call that distance R. And it is on a directed ray with an angle of direction of theta. Theta is going to go back to trig theta, where 0 starts out to the right, and we go counterclockwise around the circle. Not navigation theta, where 0 is up top. Back to trig or math theta. Okay. So, how can we find those R's and those thetas? Well, this is going to be at the point 2 comma negative 5, which we've already established. So what we can do then is we can make ourselves a right triangle, and this would be a side length of 2 there. Let me go into a different color. That kind of blends in up there. This would be 2 up here, and this would be a side length of 5 over there, even though it's down, so really technically it's 5, but we'll make it a side length of 5. So our R value, we can use the Pythagorean theorem. So it would be the square root of A squared plus B squared. We can use the Pythagorean theorem for that. Okay. To find my theta, that's going to go back to our old friend. We're going to use theta prime, our reference angle. Okay. And that's going to be the inverse tangent of B over A with the condition that we drop the negative symbols. And then, because that's our reference angle, in quadrant number 1, theta is our reference angle. In quadrant number 2, theta is 180 degrees minus our reference angle. In quadrant number 3, theta is 180 degrees plus our reference angle. And in quadrant number 4, theta is 360 degrees minus our reference angle. Stuff that we've done many, many times over the course of second semester. Okay? So, if z is 2 minus 5i, which is the same as 2 comma negative 5, how do we write our complex number in trig form? Okay? Well, we should first know what our trig form is. The trig form of a complex number is going to be r times the cosine of theta plus I sine of theta. So you need to find the r value and you need to find the theta value. Okay? So let's do that right now. Let's put 2 minus 5i into the trig form of a complex number. Okay? So first off, we're going to need to find r. R is the square root of a squared plus b squared. So my a value is 2. My b value is negative 5. So this is going to be 2 squared plus negative 5 squared. 2 squared is 4. Negative 5 squared is 25. 4 plus 25 is 29. So my r value is the square root of 29. To find theta prime, I'm going to go with the inverse tangent of 5 divided by 2 because I need to drop the negative sign on it. Dead of the better on these. Oh, drop the pen. Actually, here, we'll just go like this. Then I got a calculator. I just got a calculator without batteries, or with batteries.
Is I supposed to be the square root of negative 1 in this situation?
No, I is just I.
So we just keep that as like a variable.
I is just I. Yep. Trig, whoa, escape. Trig inverse tangent of 5 divided by 2. I want to be in degrees here. And so then we get, I get 68.2. Agree? Okay. So that gives me 68.2 degrees for my reference angle. But what quadrant is this angle in? Quadrant 4. Okay. So quadrant 4 is here. That means my reference angle that we found was here. So that's going to be, actual theta is going to be then 291.8. Agree with that. Okay? So the trig form of this complex number then is going to be, so 2 minus 5i is the same as 2 comma negative 5 is the same as the square root of 29 times the cosine of 291.8 degrees plus I times the sine of 291.8 degrees. That is the trig form of it. Yep. Because if you solved it, if you distributed the square root of 29 and figured out what the cosine of that was, you would get back right to here. Yep. Okay. And all of those are what z is. Okay. So there are 3 different ways to represent a complex number in math. The first way to represent a complex number is something called the standard form. That is your A plus B I. Okay. Then you have ordered pair form. And that's A comma B. And then you have trig form. Which is R cosine of theta plus I sine. Now, because where we're getting to de Moivre's theorem, which is all about roots and powers and all that fun stuff. Okay? Writing cosine of theta plus I sine of theta gets a little annoying after a while. So in math, we also shorten that to R CIS of theta. The C stands for cosine plus I sine. I is for I, S is for sine. Okay? So you can write CIS of theta also. Okay? Let's do number 1 together, and then I'll have you guys do 2, 3, and 4 on your own. Okay? Alright? So, first thing that we need to figure out is what form we're in. What form are we in for this one? Standard form, right? Okay? So, the ordered pair form for this one would be -3, 4. Might be easier for you to see -3, 4 as where the point is going to be in when we go find theta. So that's why I always like to just show you that you can always switch it into that form also. Okay. Then we need to find our R value. So that's going to be -3 squared plus 4 squared. And then we take the square root of that. So that's 9 plus 16, which is the square root of 25. So I get an R value of just 5. Agree? Okay. Then we need to come up with our reference angle. That's going to be the inverse tangent of 4/3. What did we come up with for an inverse tangent of 4/3? 53.13. What's this way? Which quadrant are we in? We're in quadrant 2. So theta is going to be, not theta prime, theta is going to be 180 degrees minus my reference angle. 180 minus my answer is 126.87. So the trig form of this z is 5 cosine of 126.87 degrees plus I sine of 126.87 degrees. Which you could also write as 5 okay? Cosine.
They just said,
Roots, then we're going to be writing this like we're taking the fourth root, we got to write this 4 different times. Shorten it up. Okay. You now try numbers 2, 3, and 4. 2, 3, and 4. Unit.
well, that doesn't power. Because it turn on
So this is going to be the point -2, comma, -2 square roots of 3. So my R so -2 squared is 4. -2 square roots of 3 squared is 3 times 4 is 12.
Yeah.
So that gives me an R value of 4. Then we've got an inverse tangent. Of 2 square roots of 3 over 2 So that's just going to be the inverse tangent of the square root of 3. So that's going to be 60 degrees. That is in quadrant 3. So actual theta is going to be 180 degrees plus 60 degrees, which is 240 degrees. So Z here would be 4 CIS 240 degrees. Yes? Okay. Number 3, this is the point 0, 8. My R value is going to be 8. My theta value is going to be 90 degrees because 0, 8 is straight up 8 units. So the distance from the center to it is 8. The angle is 90. Okay? So this is Z here is 8 CIS 90. And in number 4, this is negative 5 square roots of 3, comma negative 5. So my R value then would be negative 5 square roots of 3 quantity squared plus negative 5 squared. That's going to be 75 plus 25. So R is 10. Theta prime is going to be the inverse tangent of 5 over 5 square roots of 3. So that's going to be a reference angle of 30 degrees. Because it's 1 over the square root of 3, which is 5 over 6, which is 30 degrees. This is also in quadrant 3. So actual theta is 180 plus 30, or 210. So Z here is equal to 10 CIS of 210 degrees. Okay? Oops, I forgot to circle my answer. You have numbers 5 and 6 to do before Tuesday.